Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video I would like to explain on trees and its terminology. So basically this video I will divide it into two. Okay, the first one is the definition of tree, and the second one, so you need to be familiar with the tree terminology. Okay, a few terminology that you should know, okay, to describe a tree data structure. Okay, so from the left, okay, you see the picture of a nature view of tree. Okay, normal we have roots, branch and leaf and so on. Okay, however, okay, in the computer engineering view, you can see from the top to the bottom. Okay, root, okay, from the top, okay, so the root, the branch, node and leaf. Okay, this is the view from the sides of nature view and also the versus computer engineering view. Okay, so what is a tree data structure? Okay, a tree is a finite non-empty set of elements. Okay, there should be a finite numbers of elements for the tree, and it's an abstract model of hierarchical structure. So you can see the hierarchy, okay, hierarchy structure of a tree, okay, from the roots to the leaf, right? Okay, and then it consists of nodes with a parent-child relationship. Okay, so you can see who is the parents, who is the child, okay, how many children for these parents. Okay, so you need to be familiar with that later. Right, okay, this is the application of tree data structure. So we normally use in organization chart, okay, file system, and also of course a programming environment where you can use tree data structure to store a variety of data. Alright, okay, the concept of tree. Okay, a tree is a set of one or more nodes. We call it ST. Okay, there should be a designated node called a root. Okay, there must be one root for a tree, and the remaining nodes are partitioned into n disjoint set of nodes, which is T1 until Tn. Okay, it depends on how many nodes for the tree. Right. Okay, so this is the basic concept of tree, which is the expression tree. Okay, example of expression tree. Okay, how to read this tree? How to traverse this? Okay, so the parents, okay, the parents, okay, represent the operator, whereas the child represent the operand. Okay, how to read? Okay, you can start from the left children of the root. So which is the left one? So should be A, right? So in this case, A should be the okay, A is the left child. Okay, so A, you go traverse to the parents, okay, A plus, so you go to the right child, which is B multiplied by C. Okay, so finish subtree for the left child. Then you move to the right child. However, you need to start with the left, okay, the most left children, okay, which is D. D multiplied by E, and then plus F, the whole here, the whole thing here, you multiply with G, okay, and then you combine with the left child of the root. Okay, so now you get expression 3. Okay, this is the expression for this tree, right? Okay, so why the first picture is not a tree? Okay, and the second picture is a tree. Okay, you need to remember that one child cannot be shared by two parents. So you see, E shared by B and C. Cannot be like that. Okay, so you need to remember only, okay, one child is referring to only one parents. Alright. Okay, so this is the normal terminology, okay, for a tree. So we begin with the roots. Okay, so root is a node without parent. So A, okay, is the root. Okay, because A has no parents. Okay, siblings, nodes share the same parents. So B, C and D are siblings because it share the same parent, which is A. Okay, the internal node with at least one child, which is, okay, for this example, so you have A, okay, has B and C as a child. Okay, B has child, okay, which is F, and F, okay, is the parents of I, J, K. Okay, C also has child, which is G and H. So the internal node, okay, or nodes with at least one child. So in this case, you can see A, B, C, and F. Okay, whereas the external node, or we call it as leaf, okay, nodes without children. So it's represented using these green nodes. Okay, E, I, J, K, G, and H, and also D. Okay, because there's no child. Okay, nodes without children. Right. Okay, so the ancestor. Okay, what is the ancestor and what about the descendant? Okay, ancestor, you can see from the bottom to the top. Okay, so the hierarchy from the bottom to the top. Okay, for example, who is the grandparents of E? A is the grandparent of E. Who is the ancestor of E? B and A, because B is the parents of E and A is the grandparent of E. Okay, the relationship. Okay, you can see from the bottom to the top. Okay, whereas the descendant, you may analyze from the top to the bottom. Okay, who is the descendant of B? All of these nodes is the descendants of B. E, F, I, J, K is the descendant of B. Who is the descendant of C? Of course, these nodes. Okay, G and H. Okay, the children, grandchildren, and grandchildren. So you can see from the top to the bottom. Okay, that's the ancestor and descendant. Okay, we move to the next one. The depth of a node is the number of ancestor. Okay, so the depth of B is 1 because, okay, there's only one ancestor for B, which is A. What about the F? The depth of F? Okay, 2 because B and A is the ancestor of F. Okay, you see here number of ancestor. Okay, what about the height of a tree? Okay, the maximum depth of any node. So, for example here, okay, what is the height of nodes F? Okay, this is the height of F, but what about the height of a tree? Okay, so it's 1, 2, and 3. So that's why we got 3. Okay, as the height of a tree. Okay, what about the degree of a node? So the number of its children. So we can see what is the degree of F? 3, because there is 3 children for F. What about the degree of a tree? Okay, the maximum number of its nodes. So what is the maximum number? Okay, is there any maximum other than 3? Okay, only 3. So this example is the degree of a tree is 3. Alright, what about the subtree? Okay, the tree consisting of a nodes and its descendant. Okay, so this is the example of subtree. Okay, consists of a nodes, which is these nodes, and its descendant. Okay, this is subtree of C. What about the subtree of A? Which is this part. Okay, alright. Okay, summary of tree terminology. So you need to be familiar with the terms. Okay, root, okay, child, the left child, okay, who is the left child of A? B. Okay, right. Okay, from the right. Okay, parents, who is the parents of D? B is the parents of D. Okay, leaf node. Okay, you need to remember the interior, the exterior node. Okay, the nodes without children. Okay, so in this case, H, E, I, J, and G, okay, has no children. Okay, this is known as leaf. What about the subtree? Okay, you already know. Okay, this is the subtree. Okay, what is the ancestor and descendants? So you need to be familiar. Okay, where you can analyze from which one is you can analyze from top to bottom or bottom to the top. Alright. Okay. So what is the path? Okay. So the path, you can see the line here. Yeah, okay, the dot line here. Sorry. Okay, the dash line in the path. Okay, from A to J. Okay, this is one path. Okay, from A to C, we call it as H. Okay, the join of edges we see as, okay, is known as a path. Okay, path. Okay, degree of a node. Okay, degree of a node of a tree is the number of subtree having this node as a root. So you need to remember. Okay, so the degree of a node is the number of subtrees having this node as a root. Whereas the degree of a tree, okay, the degree of a tree is defined as the maximum, okay, the maximum of the degree of the nodes of the tree. Okay, what about the level of the nodes? Okay, you can see from the root, okay, as 1 and incrementing by 1 as we move to the from the root to the subtrees. Okay, so you see the level, okay, the degree of the nodes, the degree of a tree, and also the level of the nodes. Right. Okay, this is the list representation. Okay, how you can store. Okay, so from the root. Okay, so root must come first, followed by the list of the subtrees. Okay, from link 1 to, there should be a link, okay, to join the parents and nodes, parents and children. Okay, in this case, how many link fields are needed? Okay, okay, we can see from the data. Okay, how many links are needed in such a representation? So, referring to that, okay, how many links? Okay, so this is the example of tree. Okay, so every tree node should has object, okay, as a useful information, and also its children, okay, which is pointers to the other children. Okay, children pointer to its children. Okay, so meaning that there must be a pointer which point to the children of the nodes. Alright. A node is representing by an object, okay, which is element, consists of element. A node, yeah, you need to remember. A node is represented by an object storing element, parents nodes, and also sequence of children nodes. So you can see on the right side, this is the relationship, okay, between the parents and also the nodes. Alright. Okay, so this is the exercise. Okay, I will explain, okay, this exercise in a second video. Okay, part 2. Thank you. Okay, later we continue in the next video. Assalamualaikum.